All right, in example 8, it says sometimes we're going to use identities to solve trig equations. The identities we learned earlier in this chapter can be of great service when solving a trig equation, and we'll see that in examples 8 through 10. So first of all here, notice that we've got sine squared x in our equation, and then we just have cosine x. Here we have a mixture of two different trig functions, sine and cosine, and there's really no way to factor this so that those two different trig functions appear in the two different factors. So that is off the table, unlike what we were able to do here, where we got the different trig functions in the different factors. That can't happen on this one. And so what we're going to try to do is write everything in terms of a single trig function. Now, there's really nothing we can do with cosine x, but I know all day, every day, sine squared x is equal to something. Okay? We're going to use the Pythagorean identity. Sine squared x plus cosine squared x equals 1. Y'all, always, if I subtract cosine squared x from both sides, always sine squared x is going to be equal to 1 minus cosine squared x. So that's actually what I'm going to replace for sine squared x in here. Now I'm telling you what, those parentheses aren't going to be big enough. So I'm going to expand this out a little bit. My problem says 2 times the sine squared x, which sine squared x is equal to 1 minus cosine squared x always. Then just bring down the rest of the problem. Minus cosine x plus 1 equals 0. Now, I don't know about you, but it looks like we have a little bit of a mess. Let's do a little bit of algebra to clean this up. First of all, let's run the 2 through. So we will have 2 minus 2 cosine squared x minus cosine x plus 1 equals 0. Now, I think we have some numbers we can combine here. So we will have negative 2 cosine squared x minus cosine x plus, now 1 and the 2 combined gives us 3 equals 0. All right, now in any quadratic equation, I am not a huge fan of having a negative lead coefficient. I just think that's ooh. And we don't have to deal with that. We can get rid of that negative coefficient by either multiplying or dividing both sides by -1. Really, I'm going to look at dividing each term by -1. I can totally do that legally. Now this makes me a little bit happier inside. Positive 2 cosine squared x. Now this is going to be a plus cosine x. Now we're going to have a minus 3 equals 0 divided by -1 is still just 0. Okay? So you can change all the signs in your equation by doing that little legal algebra move. All righty, let's see if this one is factorable. Got to just trial and error some stuff. I think if it is factorable, I'll have a 2 cosine x there and a cosine x here. All right, I want to find how outer and inner combine, but also I know last times last needs to multiply together to give me a -3 if this is factorable. So let me try maybe a, I don't know, a -3 here and a +1. Now, let's FOIL that out. I'm going to kind of get outside of my paper here and FOIL that out. 2 cosine x times cosine x is 2 cosine squared x. I knew I would like that. Outer times outer is 2, right? 2 cosine x times 1. So that's just going to be 2 cosine x. Inner times inner is -3 cosine x. Last times last is a -3. Okay, now I almost like this, but I don't, because this is 2 cosine squared x, and this is going to be a minus 1 cosine x. I need a plus 1 cosine x. Ah, shoot. Well, let's go back to the drawing board here. What if I would say, man, that was so close, but close doesn't count. Let's see, what if I would do, well, I already forgot what I did here. Okay, what if I would do a positive 3 and a negative 1? That would give me 2 cosine x. Outer times outer is actually going to give me a negative 2 cosine x. Inner times inner is going to give me a positive 3 cosine x. Now, when those combine, that gives me a positive 1 cosine x. All right, I'm liking this. Y'all liking all of this? And then we'll bring down the equals 0. Now that we've got that factored correctly, hooray, we are ready to split this apart. Okay, we got a factor times a factor equals 0. So 2 cosine x plus 3 equals 0. And my other equation is cosine x minus 1 equals 0. Let's solve each of these little equations here. So first of all, isolating the cosine by subtracting 3 from both sides leaves me with 2 cosine x equals a negative 3. Divide both sides by 2. So cosine x equals a negative 3 over 2. You know what that is? Negative 1.5 if you want to write it in decimal form, and this is actually not going to be in is not going to be a number that will work out. There's not an angle that has a cosine value less than negative 1. Okay, let me write that instead. Less than negative 1. Okay. So the solutions that we can get from here are no solutions, none from that equation. Okay? You could punch in on your calculator inverse cosine of negative 1.5. It'd give you math sass. Over here, solving this next equation for cosine x, add 1 to both sides. Okay? Solving for x. Take the inverse cosine of both sides. Okay, so that says we're looking for the angle or angles that have a cosine value of positive 1. What angle has a cosine value of positive 1? Okay, remember, if you want to set this up, this angle right here, which would correspond to the ordered pair 1, 0, this angle has a cosine value of 1. So 0 and 2 pi and 4 pi, etc. But if you look at the directions above, oh, I can't quite see all that. Okay. If you look at the directions above right here, you only want to give your solutions that would include 0 but not 2 pi. Okay, the bracket means include 0, but not 2 pi or anything greater than that. So my only answer is going to be the 0, x equals 0. And if we want to keep with the same way of writing in solution set form, we put that in a fancy little brackets. So our only answer is 0. Now these would check, but they're outside of that interval from 0 to 2 pi, so we don't need those, just 0.